Okay, this is the second video about investigation 2. So we're continuing to think about limit statements, and in particular, we're going to use them to define vertical and horizontal asymptotes in a more precise way than in pre-calculus. So for problem 2, the question asks, which of the following asymptotic statements describe the limit statements below? Note that some statements may not be used, and some may be used more than once. You may find it useful to first sketch a graph of each asymptote and of each limit statement below. So ultimately, we know that this question is a matching question, and so we can kind of just take the hint that was given. So like if I imagine what a vertical asymptote at x equals 2 would look like, so that should be a vertical line at x equals 2, and then I don't know what else is happening with the function, but I know that from the left or from the right, or somehow it should be approaching towards this vertical line. So I'll just kind of keep that there for the moment. And for part B, I'll draw it off to the side because there's not so much space, but if I were to have a vertical asymptote at x equals 3, it would look very similar. It's just that it would be at 3 instead of at 2. And then likewise, if I had a vertical asymptote at x equals 4, it would again just be shifted over by 1 unit. So this is kind of like what we think vertical asymptotes look like. And then if we're talking about horizontal asymptotes instead, then basically the main difference is that they're going to be on the y-axis now. So if I'm talking about y equals 2, I'm imagining some kind of horizontal dotted line at y equals 2, or y equals 3, or y equals 4. And again, I don't exactly know where the rest of the function is going to be, but I expect it to have something to do with that. And none of the above, well, that's just none of the above. Okay, and then also I can imagine a function corresponding to these limit statements, and then after I kind of draw what it looks like, I can look and see which one does it match above. So for the first one, we have a limit as x approaches infinity of f of x equals 3. So what I know is that x is going to be approaching infinity, and y is going to be approaching 3. So the only part of the graph that I know about really is kind of like over here. And so basically, kind of like eventually, I don't know exactly what it's going to look like, but maybe it would look something like this, right? Theoretically, it could also maybe look something like this, or something like this. I don't know exactly how it approaches, but I know that it approaches. And then I'm going to take this picture that I just drew, and I'm going to see that it's a pretty good match. If I look at all of the pictures that I drew, the one that matches with it the best is this one. So I'm going to go ahead and say that the answer to the first one is E. So E is good. Okay. And let's continue. So the next limit statement is that the limit as x approaches negative infinity of f of x equals 2. So let's draw it on the left side. So now I'm told that x is approaching negative infinity and y is approaching 2. So I'm looking at the part of the graph that's over here. And again, I don't know exactly how it approaches, but let's say it looks something like that. So I can compare this to the graphs that I drew above, and it seems like the one that matches the best is D. Okay, now the next limit statement says that as x approaches 2, y approaches 3. So what would that look like? So I have x getting close to 2 and y getting close to 3. So, well, let's make it like a round circle. That graph might not go through that point. It might not be defined there, or it might go through a different point. But let's say that the function might look something like this, right? Now, when I go up here and I look, oh, sorry, we just used D. Actually, I'm not going to check these off because we know that it's not exactly a one-to-one matching. But when I look at all of the graphs, it doesn't really match with any of them. So I'm going to go ahead and say that this is probably none of the above. Okay, the next one is the limit as x approaches 2 from the right of f of x equals negative infinity. So now x is getting close to 2 and a little bit greater than 2, and y is going to be down at minus infinity. So this graph is looking something like this, right? I only basically know about this part of the graph, not the entire graph. And the picture above that matches the best is picture A. Looks like a vertical asymptote at x equals 2. Okay, continuing on, the limit as x approaches 4, so x is approaching 4 from the left, and y is approaching positive infinity. So our graph, well, we don't know, it could be anything, and then eventually, though, it's going to look like that, right? So I don't know anything but about this part of it, and this looks like a vertical asymptote at x equals 4. So I'm going to go ahead and say that this is, oh, sorry, wrong pen. I'm going to go ahead and say that this is C. Okay. And then when we have a statement like the next statement, that the limit as x approaches infinity of f of x equals infinity, so both x and y are approaching infinity, so maybe the graph looks something like this, right? So when I compare that to all of the graphs above and think about whether that graph I just drew seems to have an asymptote, it doesn't. So this one I believe is also none of the above. And similarly, the last statement says the limit as x approaches infinity, so x is still approaching infinity, and y is approaching negative infinity. So that's going to be, it could be anything, but the part we know for sure is that it's going to look something like this in the long run. And again, this one is not having any asymptote, so this is none of the above. So this kind of is like a good review of the limit statements and what they look like in terms of the graph, but also we can go further and use this to think about what types of limit statements had vertical and horizontal asymptotes. So in particular, we have vertical asymptotes for A, B, and C, and this was when x was approaching a number and y was approaching infinity. And we had horizontal asymptotes for D and E, and this was when x was approaching plus or minus infinity and y was approaching a number. So it makes sense intuitively in terms of the graph, and we can use that intuition to write down a definition for horizontal and vertical asymptote in terms of limit statements. And this is the definition that you will use to justify any problems about horizontal and vertical asymptotes in the future. Okay, so yeah, so basically we say that a function has a horizontal asymptote at y equals c if the limit as x approaches infinity of f of x is equal to c, or if the limit as x approaches negative infinity of f of x is equal to c. So as x goes asymptotically large in either direction, y approaches a fixed number. And on the other hand, we say that a function has a vertical asymptote at x equals c if when x approaches c, either from the left or from the right, so let's start with from the right, the function approaches infinity or minus infinity. Okay, so this is already two statements, and then there would be two more because x could approach c from the left or from the right or both. So if at least one of these statements is true, then we say that the function has a vertical asymptote at x equals c. And x equals c is the equation of a vertical line, so it makes sense.